Hi, this is Jeff Heaton. Welcome to Applications of Deep Neural Networks with Washington University. Okay, it is time for the Kaggle competition. This is something I take the students through every semester that I teach this course. And those of you that are following along out in internet land, this is your chance to follow along with this Kaggle competition. It will start on October 21st, so in about a week from now, it will actually begin, and then it runs until November 18th. So that's just under a month. So it's not a real long drawn out Kaggle like some of these that will go on for 3 months, but it gives you a chance to use some of the technologies and techniques that were covered in this course. Now, you don't have to be a member of the course to actually take place in this. You can use the Kaggle URL that I will publish on the 21st, October 21st, 2019, when this actually begins. For the latest on my AI course and projects, click subscribe and the bell next to it to be notified of every new video. Okay, so I've had a number of Kaggles in the years as I've taught this, starting in 2016, and usually 2 semesters a year. And this is always something the students enjoy. And I definitely invite you as a member of the internet community to go ahead and try this. Even if we're past when this Kaggle starts, it still could be a good learning experience for you. But if you're in the fall 2019 semester up till mid-November when this cuts out, you can compete right along with everybody. This is going to be natural language processing this year, but I'll introduce that in a second. Just give you a teaser. There's going to be a much more in-depth video in a week on the 21st when I release this of October 2019. So let's look at the last semester. The last semester was basically where I took some data. It was from zip codes, and the students competed on it. You can see here. One student, now the challenge always for me is generating these data sets. And sometimes students can figure out literally how to reverse engineer where I got the targets from. And in this case, the students were able to do that. So this one team did quite well. They reverse engineered my algorithm. That doesn't always happen, but you can see by the number of entries, there was a lot of competition going on here. And I gave just a mean score prediction. That's the benchmark, and usually you want to be above that one. But this shows all of the team members, and there was a little bit of an upset here. Some teams moved up and down at the end as a result of overfitting. So you're going to essentially get sentence pairs. And these sentence pairs, so it's a classification, so you'll be using a log loss most likely. And I'll give you 2 sentences in a CSV file. The CSV file is probably going to have just 3 columns. Sentence 1, sentence 2, and then what you're trying to classify. You're saying, are these sentences similar or are they not? I'm not even having you predict the degree to which they're similar, although most likely you'll not want your neural network to predict 0 or 1. You're going to want to predict at a range between 0 and 10. So 0 would be completely dissimilar, 1 would be very similar, and that's just your program's guess. In the data, it's always going to be 0 or 1. So it's binary in the training and test data. So these are some examples of similar sentences. Now, I am extracting this from a data source and pre-processing it a bit. So I've got a program set up to actually extract this data. I'm not going to tell you a lot about where this data comes from, because the challenge with these Kaggles often is, and in real Kaggles too, you can try to figure out where the data came from and maybe use that to give you an advantage. Everything is fair in a Kaggle. So you can try to find original data and use that to help you, or you can work on producing pure models to solve this. I recommend doing the more modeling approach, but you can definitely do a combination of the 2. So let's look at this first sentence. The Roman form is used in most printed material. It consists of a small loop with an arc over it, and then there's an A in parentheses. Now that A in parentheses was probably a figure in the original text, so that didn't get transferred because this is pure text. But hey, that's the way it is on these kind of data sets. So you'll have some loss of data. Now, using domain knowledge, meaning using stuff that I know from my experience, when they say Roman form, they're talking about the Roman font. And Roman fonts are different than some of the other fonts. So it's talking about a font and printed material. And then it says it consists of a small loop with an arc over it. Then down here, let's look at it. In most languages that use the Latin alphabet, denotes an open, unrounded vowel, such as, and those are probably images, they got cut. But this is enough. If you were to really analyze these, okay, Roman and Latin. Latin was what the Romans spoke, the Roman Empire. So there's a lot of connection there. Alphabet and font, a lot of connection there. Vowel and this kind of thing. So you'll probably want to use Spacy or WordDevec or something like that to reduce these down. Fundamentally, what you're going to do to make this work is you're going to extract features from here. You can't really just dump the sentence into a neural network. Maybe you could with an LSTM, and I would suggest maybe trying, if you want to get really advanced with this, trying that in conjunction with other things. But fundamentally, you're going to try to kind of break this apart. Now, I'll talk more about this next week. I'm just giving you a overall introduction. Another one, just look at this. Deeply shadowed cavities. At this point, I'm like, what? Are they talking about teeth? Can achieve an effective albedo approaching the zero of a black body. Okay, I have no idea what they're talking about there exactly. By the way, I did not write these sentences. So another thing I'll have to say too is these sentences are mined directly from the internet. So if there's profanity, if there's... I try to filter that as much as possible, but this is raw data from the internet. And in Kaggles, very often they will have raw data from the internet. So there can be interesting things in there. I try to filter that as much as possible, but if you do see something potentially offensive, it's internet data. It's not my data. But let me know if you do. I'll probably remove it. But I've got a pretty good filter running on there. But then I see this. Single scattering. I do not know what that word means. I'll be the first to tell you. Albedo is the measure of diffuse reaction of solar radiation. Wow. Okay, so it's physics or something. So let me go back to there. So these are the same. So scattering, okay, that has something to do with diffusion. Electromagnetic, all of that. Cavities probably means something missing to achieve effective approaching the zero of a black body. So this is probably talking about dark matter in physics. I guess. I don't know. But those are similar sentences. So they would have had a 1. That would have had a 1. The allegro that flows continuous to express homesickness is faster 12-bar blues. Maybe talking about music. If it pleases symphony audiences as a light, jolly piece, a series of impressions musically expressed succeeds. Talking about music. Now, the challenge here is there's not a lot of common words between these two. So you're going to want to engineer features out of these, like common words, definitely. The fact in this one that you saw albedo and albedo here and here, that is important. The fact so a common feature that I've engineered in cases like this is do some statistics. See how common each of these words are in the corpus of words that you have. Maybe pull them all together. That's probably a rare word. The fact that a rare word is in here and in here, that's significant. Engineer that as a feature. A word that is not so important, like can, the fact that the word can was in both doesn't matter as much. So anyway, just some ideas there. Now, not similar, just to give you a few examples, Calvinists engage in widespread destruction of religious art in Low Countries. It's probably talking about Europe. For Martin Van Buren before he became president. County, countries, not really related. A U.S. president. So these two are not related. Iowa experienced a growth boom when oil struck in 1930. Oil companies came to try their luck in the Iowa. Okay. That's talking about the history of the state of Iowa. This one's talking about cats. So, though there are now single cats living within the United States country, the species is largely being expatriated from the United States. So you'd have to be careful. In some of these hierarchical things, it would say Iowa is a U.S. state. Oh, we're talking about the United States. But no, those are completely dissimilar. Her keel was laid down. A keel, that has to do with ships. November 1939 by Blom and Voss in Hamburg as yard number 529. Okay, shipyards. That's where ships are built. Again, that's me using domain knowledge that I happen to know. The Charvelel musket enters service in France. Well, that has nothing to do with that. So this will be interesting. I mean, you can get extremely advanced with this. And if you want to, I'll talk about some advice that I have. If you want to go more at the simple range, or if you want to go crazy on this one. But this is just a quick introduction to the Kaggle. We'll go deeper next week. Thank you for watching this video. If this sounds like something interesting to you, I hope you will take place in the Kaggle competition. And even if you're catching this video in the future, after this has already ended, you will be able to see the top submissions by students and others posted on the Kaggle website.